I'm leading engineering there, even though I like to refer to myself as a core contributor because it emphasizes the openness, flat structure, and overall DAO ethos we value a lot. This is a workshop stage, so I will not use this presentation as a marketing pitch for a DeFi app, even though I must say I will refer to DeFi app as an example of a technical concept that we are building. So basically, my goal for today is to fill your heads with sufficient technical, high level though, but still technical details of how Passkeys work and how account abstraction work and how they can work together. And so, yeah, let's get going. So, what I'm going to talk about today is like what is account abstraction and why it's important. I will walk you through ERC-4337. That's kind of a golden standard in the Ethereum ecosystem for the account abstraction. I will tell you about the limitations and challenges of ERC-4337. And then I will tell you about Passkeys and how Passkeys can actually help overcome some of these limitations of this standard. At this point, I wanted to basically demo Coinbase Wallet. That's one of the rare providers that, at this point, integrated Passkeys. But I kind of, for the sake of a time, I kind of put that out because at the end, I will show you how actually the product I'm working on, defi.app, works. And basically, it has all the same concepts as a Coinbase Wallet, plus some of the additional topics that I will also explore within this presentation, such as chain abstraction, gas abstraction, and session keys. And we'll finish up with the questions. Okay? So, the first question, why do we need account abstraction at all? This is a crypto conference, so probably you know everything about the principles on which the cryptocurrencies and blockchain are built. So you know about decentralization, you know about how crypto is censorship resistant, you know about transparency and traceability of crypto, at the same time providing full financial privacy. And yet, how you know me friends usually interact with the crypto. They create an account on some centralized exchange, registered on some offshore location. They upload a photo of their passport to their unencrypted database. They give this centralized exchange all their credit card details so they can on-ramp fiat. They buy crypto and they hold this crypto on the centralized exchange, praying that this exchange won't rug them, that it won't get malicious as FTX did. They would need to pray that this exchange won't get hacked, and so on. And why do you think the reason for that is? I think the reason why most of the users interact with the crypto in a way that's completely opposite of the values on which the crypto was initially built is because interacting with crypto is so hard. Let me give you one example. Yeah. Let's say this guy who basically interacts with a MetaMask, let's call him Bob. So like Bob discovered some very new hot meme coin there and he wants to buy this meme coin. He would go and to centralized exchange to do the fiat on-ramp because other kind of vaguely decentralized fiat on-ramp providers are heavily expensive. So he will go there, he will on-ramp some dollars and get some USDC, some stable coin. And then he will try to buy this meme coin on the centralized exchange, but he will figure out this meme coin is not listed yet on the centralized exchange. It's hot still. Then he will figure out, okay, I need some wallet. He will go, download the MetaMask, kind of struggle with the seed phrase, set up the account. He will withdraw this USDC from centralized exchange, and then he's good to go to the Uniswap and to buy this meme coin. But when he comes to the Uniswap, he figures out he needs ETH to pay for the gas. He goes to the exchange, on-ramp more dollars, buy ETH, withdraw this ETH. Now he figures out he is good to go, but this meme coin is on Solana. So now he needs to bridge this USDC from Ethereum to Solana. He Googles bridges. He finds like CCTP, Circles Bridge, as one of the most reliable ones. But settlement time is half an hour. So he waits for half an hour. And now he has USDC on Solana, but now he needs Sol token to interact with the Jupiter and buy this meme coin. On-ramp more, fight with the gas costs in the meantime. He needs to set up gas limits sometimes. He needs to kind of figure out the gas price sometimes. Transactions fail, it gets stalled. And like, while he does all of this, like the price of this meme coin went 3x at the same time, and like he gives up, he goes away. So this is kind of the usual user experience of kind of normie people trying to interact with the crypto in a way how it's intended. We basically, as builders in Web3, identified how painful this journey is, and we strongly believe that account abstraction is one of the ways how this user experience can be made more seamless, more secure, and easier to navigate. So, what is account abstraction? According to definition from ERC-4337 IO, this kind of a community of protocols and people kind of vouching for account abstraction. Account abstraction moves crypto from the current approach of simple, externally owned account, where one can lose everything with a small mistake, to a future where an account can be tailored to their needs using smart contracts. The shift from EOAs to smart contract wallets with arbitrary verification logic paves the way for the series of improvements to wallet designs, as well as reducing complexity for end users. As you can see, this definition of the account abstraction is kind of abstract itself. It's best to understand it, it's easier to understand it if you go and look at the characteristics that account abstraction should satisfy. First of them is a separation of the control and the ownership. So, like, this characteristic means that entity holding the funds should be separated from the entity basically controlling these funds. And this entity owning the funds should be programmable wallets. So basically, these are on-chain wallets, which should support customizable logic, first of all, of signing schemes, so that they should kind of programmatically define who and under which circumstances can control the funds on these wallets. They should support recovery and other things that should be kind of changeable over the time. Account abstraction should support gas abstraction. It means that users should not be required to pay for the gas. Instead, the gas should be able to be sponsored by third-party entities, or users should be able to pay this gas in tokens different from the gas token. So they can pay in any, for example, ERC-20 token. Decentralization. So the account abstraction should not introduce centralized point of failures and should kind of keep up with censorship resistance. So it should not open up to some censorship opportunities there. And finally, account abstraction should be backward compatible, meaning that no hard forks on the networks or changes to the existing protocol smart contracts should be required. And the way how these characteristics are implemented in the Ethereum system, in the Ethereum ecosystem, was laid out in the EIP-4337. That's Ethereum Improvement Proposal, written by Vitalik Buterin himself and a group of authors in September 2021, but it came into use only in early 2023, so like half a year, one year and a half ago. This proposal introduced, I don't know if I have a pointer here, yeah, I have, but you can't see it. Anyway, we have a new object, which is kind of pseudo-transaction object called user operation. So this is kind of one big piece of this proposal are the user operations. Previously, user would compose, sign, and send transaction objects to the RPC nodes. Now, user composes, signs, and sends user operation. This user operation lends an alternative mempool, user operation mempool, that's completely separate from the transaction mempool. There is a new class of actors called bundlers who listen to the user operation mempool for the new user operations. When they find the new user operations there, they bundle them together in a kind of a standard transactions, like normal transactions, which are basically passing the data from the user operation to a new specialized smart contract called entry point contract. All of them, so basically they become normal transactions, and they become executed and added to the Ethereum blocks or any EVM chain blocks as a normal transaction alongside other transactions. Looks simple, right? So it's not rocket science. But there are some kind of technical details. behind it. But okay, here they are. So this kind of sequence diagram goes a bit technically deeper in like what's going on in the background. These kind of green people here, they are like real life off-chain actors there. So there's user, there's a bundler. These here are smart contracts that are deployed on the chain. So the process starts with the user who creates and signs user operations and sends it to this alternative user operation mempool. Then bundler comes, listens to this, picks up the user operations, which let's say only one user operation is taken, and then he uses the call data from this user operation and submits it to this entry point contract. So this is one singleton contract for the whole chain. So on each chain, there's only one entry point contract shared between all account abstraction providers there. Important contract here is the account contract. This account contract represents this user on chain. So each user has their own account contract, and that's a smart contract that holds user funds. And when, for example, this user wants to deposit on Aave or wants to swap on a Uniswap, basically the account contract is the one that will be seen by Aave or Uniswap as a message sender there. So basically all the funds are there, all the interaction with the rest of the contracts on chain happens through this account contract. Okay, so user basically created signed user operation, bundler picked it up, he calls entry point contracts function, handle user ops. What this contract does, he checks if the smart contract for this user exists. If not, it deploys a new instance of this contract using a factory contract. So the user should specify which factory should be used. So there could be multiple factories. User pick up one factory. It contains like a boilerplate template of how this smart account contract should be created. It contains all the rules of the signature validation, or the way how this basically user would prove that they control this account contract. So this new smart contract, account contract, gets deployed if it doesn't exist at this moment. And then entry point calls this function validate user operation of the account contract. Now, this smart account contract verifies signature of this user operation and verifies that this user who submitted has a right to control the funds and to do interactions on behalf of it. If that's okay, then this account contract interacts with other protocols. So at that moment, the assets get swapped on the Uniswap, they get transferred, they get deposited, withdrawn, and so on. If all of this passes, the account contract should send fee in form of ETH to the bundler to compensate for the gas costs bundler had when they submitted this transaction. In case that user wants this user operation to be sponsored, they need to set paymaster contract. So they say, okay, I want this guy to sponsor my operation. If that's the case, then entry point contract would go to the paymaster contract and call this validate paymaster user operation. And then they will basically ask paymaster, are you okay with this to sponsor this user operation? If so, everything is okay. And all of this is just one like a transaction, so this yellow line. Now this transaction is being processed, added to the block, and operations continue as normal. So this is how ERC-4337 works. Now let's see how it's currently going with the adoption. So,
does it actually work?
It does. It does, yeah. So these numbers show how it currently works. So as I said, ERC-4337 went into, let's say, production in January 2023.
So there are transactions currently being sponsored on the blockchain?
Yes. Yes, they are. Since then, so in like these 20 months, we got 16.6 million of the user of the smart accounts deployed on 6 major chains, EVM chains. And at the same time, 72.6 million of user operations being submitted and sponsored at the same time. So this looks great, right? Well, not really. If you compare what happens like outside of the account abstraction on these 6 chains, we see that at the same time, like 681 million new addresses were identified on these 6 chains, and 4.8 billion of transactions were processed. So it means that around 2% of all new addresses on the blockchain are smart accounts, and only around 2% of all transactions that were added to these 6 chains are actually user operations. So, obviously, the adoption of account abstraction is lagging. There are a couple of reasons for this. First reason is that the same elliptic curve is used for the signatures as it's used with the regular transactions. That means that the private keys are still required. So, user, in order to basically sign this user operation and to have it on-chain verified, still needs to have a private key. And they still need a MetaMask or a ledger which will hold this private key and facilitate the signing of the process. So basically, all initial impracticalities that existed, they exist still with the account abstraction, but there are additional hurdles as well, because you can have a smart contract that's basically you interact with it using your private key in the MetaMask, but the MetaMask does not know about it. So basically, they allow you just to sign some weird messages. And it means that when you open the MetaMask, it can look empty, even though you have certain funds on your smart account. Secondly, the gas sponsorship markets are quite underdeveloped at this place. So there are still not too many incentives from the third-party providers to actually sponsor these user operations. You can rarely see this actually in practice. One of the few examples where this actually exists are kind of very closed systems of certain perpetual protocols. But in order to have all these benefits, you need to create an account on their side, new smart accounts, you need to deposit funds there, pay the gas for depositing, and then you can just use few basic operations on these perpetual protocols, like opening and closing your positions, adjusting your perpetual positions there. Sometimes you still need to hold like USDC and USDT, and they will take this as a gas token and then convert it to ETH. So basically, it's quite underdeveloped and didn't find kind of a good use case still. And finally, we have a lack of compatibility with the existing infrastructure. So basically, as I said, with kind of the fact that private keys are still required and that wallets do not recognize it, that's basically the thing, that user cannot kind of very easily switch to the account abstraction at this point. Vitalik wrote a new EIP-7702 a few months ago, which proposes basically converting EOAs into smart accounts. So there's kind of a special type of the transaction that EOA can convert itself to a smart account. It's still very theoretical and didn't come into practice. I will get back to these two a bit later, but let's see how the first roadblock here, so this elliptic curve being used for signatures, can be tackled with the passkeys. So, passkeys, for those of you who haven't seen passkeys yet, passkeys are a new credential system that was proposed and built by FIDO Alliance. FIDO Alliance is the alliance that vouches for the passwordless authentication. So it has nothing to do with the blockchain and crypto. Their proposal was built on WebAuthn standard. That's a symmetric cryptographic algorithm for which uses P256 elliptic curve for signing. Let me just quickly remind you what asymmetric cryptography means in terms of signing. So the idea is that every user can generate on their own, on their local machine, combination of private and public key. Any message can be signed with a private key, and then they can provide to anybody who's interested the message and the signature. And comparing message and signature can easily calculate the public key. And then basically user can compare this calculated public key with their public key, and that in that way it can be verified uniquely that this user actually signed this message with a private key without exposing this private key. So this is kind of what asymmetric cryptography is when it comes to the signing. We have the same or similar asymmetric cryptography with a blockchain. So basically your wallet, which is derived, your wallet address, which is derived from the public key, has its own private key. And all the transactions are signed with this private key, submitted on-chain, and on-chain verified if basically this wallet signed them. And the idea how to basically use this asymmetric cryptography for the authentication was what is this FIDO Alliance is proposing about. So they propose that Web2 applications should not ask you to have passwords there. Instead, you should have the locally generated combination of private and public key. And when you register to some Web2 application like Uber or something, you should just send your public key, which is kind of your username, to Uber directly. They would store it in their database. When you log in, when you want to log in, they would send you a challenge, some small text. You sign it with your private key and send the signature to them. They calculate your public key and they verify that you are basically the one controlling this username or a public key. They would give you the session authentication. So in that way, you don't need passwords anymore. The major breakthrough of this standard passkey credential system was made maybe just last year when it's seeing kind of a massive adoption by the major technology providers like Google, Apple, and Microsoft. What they do, in the devices you have, whichever like the producer they are, they have on them security enclaves. Security enclave is executable environment existing on your device that's completely separated from your operating system. It means that no application can access the data of the security enclave there. So basically, it cannot be compromised. What they do is they store this private key of this P256 curve, so of the passkey, they store this private key in the security enclave, and they allow any message to go in, get signed, and they give out the signature of this. So the private key never leaves their security enclave, cannot be compromised. And the idea is basically to have these passkeys integrated with numerous Web2 applications. We've seen this already. So in many applications at this moment, you can still authenticate with the passkeys there. So that's kind of what the passkeys are about. So basically the challenge, Uber sends you the challenge. This challenge goes into the security enclave, gets signed there, signature comes out. What they built on top of it, and that's a really cool thing, is basically you unlock this security enclave, or actually you allow the message to go in and get signed by your biometrics, by fingerprint or face scan or with a PIN. So that's basically the ways how you can basically unlock and you verify that you want certain challenge or certain message to get signed. If blockchains used P256 elliptic curve for signing transaction, that would mean that you wouldn't need MetaMask or a ledger for signing transactions. You could use these security enclaves of your devices, and the private keys there, they could be basically the private keys signing things. So that would make things much, much, much easier. You would definitely be able to sign transactions with like your fingerprint. Unfortunately, blockchains like Bitcoin or Ethereum do not use, or Solana, they don't use this P256 curve. They use another curve called SEC P256K1, which is similar. That's again asymmetric cryptography, that's again elliptic curve, but it's not compatible with this one. So you cannot, unfortunately, use these passkeys to sign transaction on blockchain. And this is the precise moment when the account extraction can be used to leverage these passkeys to make this user experience very, very seamless and smooth. So if you remember, this diagram, this diagram. So basically, you have this validate user operation. And this account contract can implement any custom logic of verifying and validating the signatures to verify that this is user. In its basic implementation, it uses the same private keys as blockchains. But what we did, we used the implementation of the smart accounts that use P256 curve, which allows that the user operations get signed by the passkey. So you cannot sign transaction with a fingerprint, but you can sign user operations with them because they have a custom signing verification logic implemented there. Downside of verifying passkeys on-chain is that it costs 300 gas to verify P256 signature on-chain. And that's quite expensive for the Ethereum mainnet. It's not so much a bigger problem for other EVMs, L2 specifically. But there's also kind of a proposal called EIP-7702, which proposes adding a precompile to the EVM machines, which would, and if that basically would be implemented, it would cost only 3K of gas to verify basically passkey directly on chain. However, with the improvements we also introduced, there in defi.app, in the product that I'm building, we find a way to basically overcome this, and these are basically using cross-chain sessions. However, not only that we in the defi.app allowed users to sign their effectively transactions with a fingerprint, with a face scan, and with a PIN instead of having a MetaMask there, we also decided to introduce chain abstractions. The key reason is the signatures are chain agnostic. So basically, when you compose transaction or you compose user operation, you sign it locally. At this point, it doesn't know on which chain it will end. Only the bundler and the RPC node to which you submit it basically define the network on which they will be executed. However, when you sign it, when you compose it, it's chain agnostic by itself. What we did to make the whole product chain agnostic, we introduced support for Solana and 8 biggest EVM chains. That allows us to give access to the users that's basically maybe between 80 and 90% of the whole on-chain liquidity. So when we support these 9 chains, users have access to 90% of the liquidity that exists on the chain. And then we said these grandmas trading bitcoins, trading meme coins, they don't need to know on which chain this meme coin is. They don't need to know. That's additional information that they don't have, that doesn't provide value to kind of, especially to the normie users, to know on which chain the assets are. So if this user, the Bob, this guy, has USDC on Solana, has on Ethereum, on Arbitrum, what we do, we aggregate all of this and we show just one balance of USDC. In order to do this, we used some of the aggregations that already exist there. We introduced some new aggregations. It introduces certain risks there, but we tried kind of to find a good compromise between good user experience and security. Currently, we support around 12,000 different assets there, and maybe 2,000 or 3,000 of them are basically aggregated. They exist on multiple chains, but user would see them as just one asset. In order to make everything quite smoothly, we, in the background, integrated multiple bridges so that user can kind of seamlessly bridge tokens from one chain to another where they're needed. And we also integrated more than 30 DEX aggregators and intent-based networks. So we kind of facilitate very easy and very smooth flow of the assets from one asset to another, and also from one chain to another. Besides this, we implemented gas abstraction, so all these user operations are fully sponsored. Every interaction of the user with the DeFi app contains some flow of the tokens. So user is swapping the token. In future, it would mean that user is depositing token, withdrawing. So basically, in every interaction, there is some flow of tokens. What we do, we take a small cut of these fees of tokens that are flowing, and we convert it in ETH and give it to Paymaster. So Paymaster can easily pay for the transaction there. So what we got here, that user don't need to hold any other asset except the one they want to swap, or deposit or do whatever they want to do it. So they don't need ETH, they don't need USDC if they don't want. They can just literally have 2 meme coins there, and they can swap them without paying for any gas, because we take a part of this meme coin, convert it to ETH, and send it to Paymaster, so that we refund them for paying for the transaction. And finally, the way how we tackle the problem of this kind of expensive on-chain verification of passkeys is that we introduce the session keys. So these smart accounts, we implemented these kind of sessions directly on-chain, which means that the user basically controlling the passkey can also decide that they can give to certain EOA, like a classical wallet, rights for a certain period of time and with certain number of user operations that they act on their behalf. How this works in practice is that we generate a new EOA for the user in each session. The private key is stored locally at user machine, like in session in the browser. Literally, it like has 0 funds. But the user submits user operation that gives all kind of these rights under these limitations to this EOA. And then basically all upcoming swaps and every other action is basically signed by this private key that exists only temporarily in user session. And that's basically what we built. I have a short 4-minute demo how it works. Yeah, this is our product. So basically you come here, you enter your email address. We allow also to connect with the external wallets, but like the primary use case is basically authenticating with the email, and in future with kind of social network providers. So basically you can use Google or Facebook account to authenticate here. We send you an email, and we require you to set up your passkeys. And this is how it goes when you set up the passkeys. Now I put my fingerprint there. It's verified and done. Now you can see that 2 wallets are generated, one that's used for ATVM wallets and one that's used for Solana. That they are all controlled with your passkeys. And now you need to deposit or you can withdraw. But at this point, so you need to deposit crypto. In future, we'll integrate with the fiat on-ramp provider, so you can basically put fiat here. You don't need to hold the crypto anymore. I'm currently depositing from my MetaMask wallet, but I can also deposit from my centralized exchange, which is something that we expect more from the people. So I'm depositing USDC on Arbitrum. This is Arbitrum. I'm depositing 8 USDC on Arbitrum. I could do this from the centralized exchange, and this is kind of the primary way how it's intended. I'm sending the funds there. Now I'm going to Base, so basically I have 8 USDC in my portfolio. And now I'm going to Base chain. I have USDC there as well. I'm depositing, I think 7 if I remember correctly. This is a wallet. This is wallet from the browser extension. But this is something I could do from the centralized exchange as well. This kind of primarily intended, like, you can send, like, we just show you the address and you can send crypto from anywhere. In future, we would allow also fiat to be sent and automatically converted into stable coins. So I deposited 8 USDC on Arbitrum. I deposited 7 USDC on Base, and we are still waiting for Base to process the transaction. And now I have 15 USDC. So basically the user at this point, they don't know if this on which chain is this USDC, and they shouldn't care about this. So they now have in total 15 USDC that's spread, in this case, across 2 chains. It could be spread across 9 chains. And what they can do now, they can atomically swap this, like 14. So basically we need to take the USDC from 2 chains, and I want to buy ETH. And the quote is getting calculated. You get basically the same amount of ETH, like a corresponding amount of ETH, and the transaction starts. So user now needs to sign it. The passkey opens up. I put my fingerprint down, and effectively I signed at least 2 transactions here, one on Base and one on Arbitrum. We have quite complex routing in this case because we need to figure out, like, are we going to take 6 USDC from Arbitrum and 8 USDC from Base? Or are we going to take 7 and 7? Like, what's the best for the user? And which is the chain that is best to get this ETH on? And as you can see now, we have user got $14, almost $14. It's not $14 because we used 9 cents. We took it out and sent it to the paymaster so they can basically sponsor this transaction. Basically, I made 2 transactions with 1 fingerprint and without any ETH initially that I would use to pay for the gas. So that's the product itself. And here's my last slide. Maybe not. Yeah, this is my last slide. Before I open up for the questions, I want to kind of pitch a bit DeFi app in the last slide. We are currently in alpha, so basically our product is still not live. You cannot use it. But this month we are opening a beta stage, and we will open the application to the users with the referral codes. These users can enter in, they can join the faction, and there is a fierce battle that's going to be there between factions and the users who collect points by doing swaps and interacting with the protocol. So more interaction means more points. There will be a ranking system between the factions, and all of them, the agents and factions, will get very significant rewards at the end of this 1-month campaign. I can't tell you much about the details. What I can tell you is that this is going to be one of the biggest airdrops in 2024. For more information about the whole competition program and like the application itself, you can follow us on Twitter. You can join our community of dappers on Discord, and you can help us onboard your grandmas into DeFi. And that's it. Thank you. Questions?
So, we are mentioning shitcoin buying, for example, but if you want to buy a shitcoin the way you do it Bitcoin, sorry. If you want to buy a Bitcoin early, you have to know the contract address. So where are you getting the contract addresses from?
We are basically 12,000 assets that we support are those that are listed on CoinGecko at this point. So we use CoinGecko. Yes. So basically, those really small cap meme coins that are not listed even on CoinGecko, even the process is it's manual on CoinGecko side, but it's very easy. If they don't pass this, they will not be visible. We kind of every hour update that we fetch the data from CoinGecko, so we have very up-to-date data about it. So you don't need to know contract addresses. You can just search it by the symbol name and so on. Yes.
How long have you been working on this, and how many people? It seems like a fairly complex.
I mean, it somewhat is, but luckily we are relying on many providers underlying. So, for example, the part of like developing smart accounts was not developed by us. We have a partnering company called ZeroDev that does this. Like a fantastic account abstraction provider, and we do this in kind of a partnership, so they kind of build custom feature for us. The core team we kind of gathered, we basically grew up from the another protocol, maybe you heard for it, Radiant Capital. It's a lending protocol, so basically we grew up from the Radiant Capital. We started in February this year, and there is like a team of 10 to 15 people in total, but on the technical side it's maybe 6 or 7.
What happens when transaction updates on some bridge or something and user doesn't get what it's intended to get?
If the transaction breaks, that's extremely good question that we are struggling a lot. Yeah.
Stuff like this, and it always broke apart and I ended up in some point that I never had in my wallet and I had to...
That's a huge problem. We haven't solved it completely, but what we do, we are first kind of having intensive testing and trying to identify the reasons for which the user, basically these transactions fail often. One of the most frequent things is the slippage. So basically user needs to set up the slippage. Often the slippage tolerance is broken, so you get higher slippage than you wanted, and transaction fails. We have kind of the whole user experience for this, depending on if it's just technical issue, like transaction got dropped, which happens a lot on Solana, we just retry. We just retry. If that fails, if it's like a slippage issue, we basically offer a user opportunity to kind of change the slippage tolerance again, so we can continue, or they can keep the current funds. So in each case, basically user decides, like, do you want to keep trying with different parameters? You want to give up with some kind of intermediary token, because we might have used some intermediary token to do the swap, or you want to basically revert to the original asset. And then if user chooses reversion to original asset, we create a new quote, new route from this intermediary token back to the original token.
What's the usage of this token that will be airdropped? What's the utility?
Well, it will be, I mean, it will have kind of multiple dimensions. To be honest, I'm not probably the right person to talk about the token utility. One of the things is that it will produce a governance at a certain point, not directly, but through some staking mechanism. It will be used to distribute rewards in future to users, yield farming on certain protocols. So we are going to, so this is just for swapping, you see. Now this is like our first version, it's just swapping. In the future, we are going to build perpetuals there. We are going to build yield farming opportunities, which is basically an integration with lending protocols primarily and asset management. There will be bribing mechanism used like as it's used on Curve between these yielding protocols. So they would need basically to vote with these governance tokens for the distribution of these rewards. So it has its own economy. To be honest, it's not fully defined yet there, or at least I'm not fully aware with all the details, but it will be used for some of these. There was also idea to kind of provide, we currently don't have fees, but at a certain point we will introduce our own fees. And there will be certain cut in the fees when the user also holds these tokens, our own tokens. So that's kind of it.
You mentioned perpetuals. Mm-hmm. Are they meant to be working the same way? So for example, if I have ETH on 3 different chains, am I opening a position on a perpetual with 3 different transactions?
In that case, we would basically, problem is that we're going to integrate with some of the perpetual protocols itself, so we're not going to build it our own. So, for example, we integrate with GMX, exists on the Arbitrum. In order, if you have ETH on 3 different chains, we would basically bridge your ETH to Arbitrum and open your position on GMX Arbitrum. So when we integrate with these kind of field, any kind of other protocols which are chain specific and not chain agnostic, we need basically to bridge your funds to a specific chain and to do the interaction there.
That is all done in the backend, so the user doesn't actually
Yes.
know on which chain.
Yeah, there's basically just one signature to do all of this stuff.
I'm thinking more about like limit orders. You have a limit order where you put an order in and the site doesn't at that point know how much ETH you actually need. Then at that point it becomes a transaction that has to be signed beforehand, and it has to be converted before your position is actually taken, and even if the position isn't taken at all.
I mean, yes, but it will basically work as it currently works with GMX probably. Yeah. So basically you would sign this or everything beforehand, and in the moment when you're opening position, we would kind of seamlessly move all your assets to the chain where the position is opened. All the signing will happen there.
With isolated margin, then it probably has to be able to take more funds from other chains while your position remains open.
Probably. To be honest, we didn't kind of think it through yet. All kind of the details around how this would work cross-chain, but like the simplest version for us would be, so just we would take your source funds from multiple chains, put it on the chain where it exists, and basically support all GMX, for example, or Gains network interactions as they are currently. So not doing something different from this. Okay.
Is this signature verification on contract side, is that open source?
Yes.
Okay.
Yes. You can go. There is kind of the zero-day implementation that we are using. There's also Coinbase Wallet implementation that they developed on their own. You can basically, these are for me only two fully known versions. There is also Clave. They're basically the authors of this Ethereum proposal for precompile. They have their own implementation, so basically you can go and check it there. It's quite similar to SECP 256K1 verification that exists currently, but yeah, a bit different. Basically, there is a different shape of the curve that's being used, so different parameters needs to be taken. Any other questions? If not, thank you again.